Hello everyone, and welcome to this hopefully pretty chill Vulkan stream. Let's see if I can get my audio settings going. Testing, how does this sound? Can you guys hear me all right? Is the music level okay? And all of that. This is kind of the follow-up stream to the Vulkan stream I did like almost half a year ago, actually, and which I feel I kind of owe you. At the same time, it is going to be me basically testing out my new Vulkan backend, which I finally got working the other day. Yesterday, really. It was kind of sort of working a couple days ago, but yesterday was the day when I was like, yeah, this is actually going to work. Let's get the visual out of the way here. Here we go, and we're gonna make sure that we can build the game. Cool, game is built. Looks good. And the stream quality looks alright as well. Do let me know if there's anything wrong with like audio levels or anything. As always. But yes, so we did a Vulkan stream about half a year ago. And the idea here was that since I am using NVRHI for my rendering, that I should be able to get Vulkan working pretty easily and conveniently. But that didn't really work out. I had some issues. I had some binding issues with Vulkan, and turns out we did almost all of the all of the work in the last stream. Hey Xluxy, would be cool to have more frequent streams or something depending on your schedule. Currently it's kind of whenever. Yeah, it is kind of whenever with my streams, unfortunately. As you may or may not know, I don't do this full time. And because of that, I kind of stream whenever I go, okay, this is cool. I could do this on stream. And it's going to be interesting to watch, and I feel like I'm going to actually, succeed in in whatever I'm doing. And I don't have any, family responsibilities or anything like that. And I typically realize that stuff like a couple of hours, 3 hours, 4 hours sometimes, maybe before the stream is about to start. Today I had a little bit of a head start because I was like, okay, yeah, I'm just doing basically cleanup since yesterday, and so I could do a stream in the evening. But yeah, I know some people are doing streams kind of regularly, every Wednesday at 5 o'clock, whatever. My work schedule doesn't really allow me to do that, or I don't know. I guess life situation doesn't really allow me to do that. What with all the kids and everything. So unfortunately, I can't really promise that is going to happen anytime soon. But you can of course always watch these VODs of the streams afterwards if you miss one of these things. And actually, speaking of last Vulkan stream we did, I was kind of planning, okay, I'm just gonna go out on a limb and do this here. Like, typically these streams are not rehearsed or anything. These things that I do are kind of like done live on stream, and I don't really like doing streams when I don't know what I'm doing, right? And typically I typically want to stream something when I know, okay, this is more or less going to pan out. The Vulkan stream didn't really pan out in that sense. We didn't get anything on screen. Turns out we did like 90% of the work correctly. But there was like a missing piece or two that kind of didn't really pan out. Anyway, without further ado, I'm going to show you what I have currently. And we can talk about it. Go sort of backwards from here. So, lo and behold, after maybe 1 day of additional work, once I knew what I actually wanted and how I wanted to solve it. Look at this. Look at this beauty. Let's put down the master volume a little bit here. Master volume 0.3, right there. So this is now running on Vulkan through NVRHI with, I don't think any engine, core engine or game changes at all. I don't think I've changed a single line of code in the core engine or the game. What I did actually end up having to do was change the shader compiler a little bit. Because what we actually ran into during the last Vulkan stream. Oh yeah, we have those PA announcements these days. What we ran into in the last stream, and I had to actually look this up today earlier because I was like, what actually happened during the last stream? But people kind of think that, okay, you're using NVRHI, like all of the backends, they just magically work because NVIDIA has done the work for you, and you know, to some extent that's true, but especially with the bindings, you have to do actually kind of a lot to get things working. And in particular, what NVRHI Vulkan wants you to do is set up your binding groups, your binding sets, I think it's called, isn't it? Let's have a look. I call them binding groups, but I think they actually... Binding group, yeah. So this is my code. Close that. My code has something called a binding group. And let's put the music down just a tad. Like so. So this is how I bind things, and you can see that we can bind static resources, and then we can bind transient resources. So static resources are things that, like, okay, we know this is going to be bound to a certain slot, and it is going to, you know, be alive for as long as this binding group is alive. So if you have, let's say, an albedo texture or a diffuse texture, you know, something that you load from disk, they can just bind a texture here. You bind it to a slot, and you give the texture here. You know this texture is not going to die because it's actually loaded from the file, and it's going to be alive for the entire, you know, game, whatever. Then you have transient resources. These are things that you don't exactly know if they're going to change or not. So you can rebind these guys over and over. For example, if you have a back buffer, the back buffer might actually be kind of pulled out from under you if you resize your window. It's going to be a different back buffer after the resize. So those guys you actually bind as transient resources, and then you call all transient resources bound. And then what NVRHI wants you to do is it wants you to bind this entire thing to a graphics state. So here we can see that, okay, we have graphics state, we have a compute state, and these are actual like NVRHI objects. And here we can see that, yeah, what NVRHI is actually doing is like, it's using these things called binding sets. And a binding set has an actual NVRHI binding set object. So the problem that we had last time is that when you're setting up these binding sets, it wants you to group them by shader stage. So if you have, you know, something that you have a buffer that's bound only to the vertex shader, and then you have another which is bound both to a vertex and a pixel shader, for example, then those would go in two different binding sets, right? And my shaders didn't really do that, and they were like, no, we're gonna bind them sort of how I've always done for DirectX. That didn't work with Vulkan. That's why we got those errors last time on the last Vulkan stream. It took some time for me to realize how I actually want to fix this thing. But it turned out to be actually very, very simple. So we have here this thing called a shader binding slot. This is kind of how I bind anything to a shader stage, right? So you have a register slot, you have a binding slot. So these are like your HLSL style, you know, register T2, for example. And then for Vulkan, you might have like a GLSL style binding slot. So you just have, you know, have a set, typically set 0, and then you have, you know, binding number, I don't know, 11 or whatever. So you can see here, layout, set X, binding Y. This thing is the only thing I needed to add. Let's make this even a little bit larger for you guys. A set index. This is not something that existed before, like 2 days ago. So it looked just like this. We had a register slot, a register type. So type is like this T here. You know, HLS groups them into types. So you have like B for buffers, T for textures, S for samplers, and so on. And GLSL does not. But GLSL has sets. And NVRHI specifically wants the Vulkan bindings to be grouped into sets by their shader stage combination. Let's see, for NVRHI, in either the layout or binding thing for Vulkan, they're offsetting the slots. Maybe that's what you're hitting. No, the slots, the offset thingy, and I think actually the Cherno was talking about this at some point. So let's see if we can search for Vulkan 0. What did I call them? 0 something. I know what you're talking about, and they have this weird little. It's too large now for me to see anything here. $1,600 hits, so it's a little stupid. We're gonna have to actually look into the NVRHI header probably. It's something with like binding offset. Yes, here we go. 0 Vulkan binding offsets. So by default, NVRHI does this. It has Vulkan binding offsets, and it binds shaders at 0, samplers at 128, constant buffers at 256, and unordered access resources at 384. And yeah, you can just like hack this and go like this. Like, yep, now we're back to 0. That's fine. But if you don't want to do that, you don't want to actually modify NVRHI, then you basically need to set this 0 Vulkan binding offset. And that's what we're doing here. You can see we are now in the group layout. So for all of the binding layouts, we just set, and now we're good with 0. Like NVRHI is trying to be helpful here, and you know, spread out these things so that it lands at like unique indices and all of that. But we don't need to do that. We're fine with with 0 bindings. So apparently I do it in 4 different places. Binding group layout, which almost everything uses, but then we have mipmap generator. This is actually a compute shader, if I remember correctly. Yeah, blah 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 blah. Yes, we have UAVs and things here. So this is the compute shader. Yes, compute pipeline. Here we go. And we have displacement effects, and then something in the resource manager. What are we creating? The samplers. Right, yeah, the samplers also need those because we're creating the standard sampler set. So yeah, that's not what we were hitting, and we actually talked about this already last time. I think I was like toggling these things back like on and off. Like, do we actually need these or not? Well, it turns out we actually do. So it's good to bring up, but this was actually a known thing already last time. Thomas Martinez says, don't get why you use Zig. Use Odin or Jai for this stuff. Much simpler. Well, I actually did that already. Go look on the channel. We have content in Odin, we have content in Jai, we have content in C3. Actually fairly recent sort of recent stuff that I built for this very game in all of those languages. So go have a look at that if you feel like you like those more. But yes, I'm quite familiar with all of those languages. So, and I still like Zig. So anyway, what was I saying? Zero Vulkan binding offsets. Yeah, so these guys are important indeed, and we just have a static const expression variable here, just setting them to 0. So the fix actually was in my shader compiler. So here in the binding resolver, and this is like, you know, after about half a year, the biggest thing is like these lines here. And I had to write a comment here because this can be kind of confusing later on. But basically what we're doing here is that we're iterating over the metadata that we have in the shader compiler. And the metadata is like, okay, it has a name, a binding slot. What kind of thing is it? So uniforms can be, you know, all of these textures, samplers, constant buffers, structured buffers, blah blah blah. And then specific things used for them. And the important thing here that Vulkan requires us to do is group them by their shader stage combination. So we have these ordered stage combos vector here, which has just an integer. This is a bit field of the different stages. So just look through them and see which one we have actually, you know, in use in the shader, and then we skip the standard sampler bindings because they're fixed. And then later on here we do this. So when we are iterating over the shaders by stage, then we assign the index for them. Set index for combo, and if we look at where set index for combo is, it actually sets this new variable here. Yeah, fixed sampler sets always have a fixed index. All of the other one get their own index. This works because the fixed samplers actually have a fixed combination of shader stages as well. So that works, but all of the other ones need this combo that we figured out. And this is the new field that I added here, like so. And now that we know the set index, now we can actually use it to generate the proper bindings in the code. So we have something called, I think is it this one? Yeah, here we go. So here we can see this is actually generating like actual like HLSL code here, and we can see set index here. This used to be just set 0 like that about half a year ago. Now it's using the set index to generate that. And with this small little change, everything kind of unraveled. And it just like started working all of a sudden. and I was kind of surprised actually at how little was needed. That of course meant that all of the materials, all of the shaders had to be recompiled. But luckily I can do that, like batch reconvert those. But yeah, that was Vulkan. We were almost done. We were so close. Well, there were some like full screen handling issues and things like that I had to fix up the past few days. That's where like most of the time actually went. But like we were so close to getting things on the screen. It's kind of silly, really. And I told you in that last stream that like, yeah, I'll probably do a follow-up when I have things working. Well, that would be now. So I figured, okay, let's do a stream today. Let's see what actually works and what doesn't, because this thing hasn't been very thoroughly tested. I was actually kind of busy yesterday evening, so I haven't necessarily done a whole lot with this Vulkan version, but we're gonna see what works and what doesn't. So far, everything kind of looks like it is working. So that's kind of nice. What does not work with Vulkan is trying to use it with the tools. So with like the level editor, for example. That doesn't work. And the reason it doesn't work, or at least, you know, my belief is that it doesn't work, is that we are creating a swap chain for the D3D backends and quite simply passing another process's window handle to the renderer. And on D3D, that just works. I don't think that's really kosher to do on Vulkan. But it is something that kind of has to be redone anyway, sooner or later, when I start moving my tools over to the cross-platform. So I'm kind of thinking that like I'm not gonna do anything before that to make it work with Vulkan, because I don't need the tools to work with Vulkan currently. Wasn't it also required for the surface? What is it in this case? I mean, I'm sure you're right, but the HP native window handle, which in your case is Avalonia. It's not Avalonia for the level editor yet. So what you're talking about is this is the audio editor. This is the only thing that is Avalonia so far, right? This guy. And this just has a node editor. It doesn't render anything you know, through the game engine. In fact, this is not even really tied to the game engine anymore. Now with this rewrite, this used to be WinForms as well. It is not anymore. But the level editor, which still looks like this is not Avalonia. And this one renders directly to the window handle, and it uses the we can do like lots of objects, for example, like this. This one uses the window handle and renders directly to another process's window handle, which I don't think is really allowed with Vulkan, which is why I haven't really done it yet. But this is not Avalonia yet. I mean, ideally it would eventually be. At that point, I'm probably gonna have to redo that window handle business, because like a view like this here, this 3D view, actually has a window handle in Windows Forms, which this is, but it does not have a window handle in Avalonia. You don't get like an H-wind for the view, so it would not work there either. So that's kind of interesting. Let's let's do something very, very basic here to begin with. I'm gonna shut the editor down for now. Let's make sure we can actually like switch graphics APIs. So exit. So we can see here in the top right corner, that kind of tells us what we have going currently. So I'm going to switch back to D3D11. And it tells me I need to shut the game down and start it again. That's fine. I'm going to do that. Right, it boosts directly into the level, which isn't maybe optimal here, but we can live with it. So I'm gonna move to D3D12. You must restart the game to apply all options, that's fine. I'm gonna take away the command line parameter here, which boots directly into the level. Alright, so now we're on D3D12, that's good. And then I actually added like an experimental flag to Vulkan. Yeah, so it says like the same thing, but then it says please note that the Vulkan render is experimental. That's just because D3D12 used to have that as well, but D3D12 I don't consider experimental anymore. It has been used now for close to a year, and it works really well. So that's fine. Okay, Alt-Enter works. This one I actually tested earlier today, that we can actually switch between like full screen and windowed mode. Actually works. What about switching sizes? That works as well. Oh, we should probably go here and lower the master volume here from the menu. That way it won't come back every time we make some changes here in the other menus. Yeah, this one seems to work as well. Very cool. Should do like a sandbox menu. I wonder if these mods are working. So this was a level that we made in a previous stream. We had this flying scout, which is actually part of a WebAssembly mod, and the mod kind of, well, it comes with this flying scout obviously, but then it also comes bundled with this test level where you're supposed to fly through these hoops. You're supposed to jump through hoops, literally. We're going to want to make sure that this one works with Vulkan as well. And it's super difficult to steer this guy, because you don't have any control in the air except just the like upwards thrust. So you have to gather speed on the ground and then just use thrust to like jump into the air. Yeah, like that. There's really no gameplay here. It just plays that sound when you drive through one of those hoops. There's no like score keeping or anything like that. So, but okay, that works. Cool. What about if let's go to depot maybe.
Channel open.
And then use some of these like UI things. Make sure all of the UI elements.
Stellar. Listening. Understood. Channel open.
Like those radio pings, for example. Everything seems to be working pretty well.
Positioning.
I will say though that the way I use NVRHI, D3D12 seems to be the more kind of optimized backend. Are you having a little bit of trouble there, Mother? It's a tight space. Yeah, the way that I use NVRHI, D3D12 seems to be the more optimized backend. I do get like anywhere between like 10 and 15% more performance out of D3D12 compared to Vulkan, at least currently.
Receiving.
Yeah, sorry about the terrible AI voices. They are just placeholders. Yeah, we can see that you can see that the light probes seem to be working, because if we turn off light probes, everything in the inside of the tunnel get very bright, including the particles. Oh, particles actually, yeah, I don't think we can actually turn on and off the particle light probe setting like this, because it's not actually a game object. Yeah, so the particles actually always have the light probes on. Yeah. Okay, well, anyway, they do clearly work. Otherwise they wouldn't be that dark. Yeah, at runtime there are certain things that actually get kind of baked into their type. You can only turn them on and off like in the editor. Not sure if I see it correctly, but Vulkan seems to be a bit more laggy. Do you mean like, huh? What? Laggy? I mean, I don't doubt that you're seeing something. There's probably an actual thing there, like an actual difference. But what do you mean laggy? Do you mean like performance is worse, or do you mean that because like I don't think you shouldn't be able to tell if there's any like input lag, right? Because you kind of need to play the game yourself to see that. I mean, it does run quite well on Vulkan. If we turn off the VSync here, you can see that we're running at like over 300, 200. Well, if we're looking out towards the nothingness, we get 300, but we're sitting at like comfortable 200 something frames here. The frame pacing is then a completely different question. I typically run with VSync on because it tends to smooth out the pacing a little bit, which is kind of neat. But yeah, there definitely might be something strange. But like I think it feels just as snappy as it does with D3D. Okay, let's do this. If I switch temporarily to D3D12, which I can do here with just a flag here, and then we're gonna go directly into that same level. Does this now look better? So now we have overridden the options menu, and we are running with D3D12, which to me feels basically identical. D3D feels more smooth. Well, that is possible. And, you know, just to be absolutely clear here, I'm not switching to Vulkan or anything like that. This Vulkan work is mostly here to, well, first of all, make it possible to make native Linux builds at some point. It's not anything I'm gonna do right now, but like the whole Avalonia thing also made me realize that hey, I could actually just run these tools natively on Linux when I'm not tied to Windows Forms anymore. And so the renderer was kind of the last thing to port there to move this tech to something else. I'm sure there's still some Windows only pieces of code there, but like the last big thing obviously was the Vulkan support there. But that does not mean that I'm kind of switching away from DirectX, not at all. D3D12 is going to be the main and default graphics API for quite some time, and especially since NVRHI is performing better with D3D12 clearly than it is with Vulkan. But yeah, how does this look? Does this look better than the Vulkan one? Is it smoother? It does feel very smooth to me, at least. But it might, of course, it might just be something with like OBS as well, right? Since these games are now rendered differently, maybe OBS has to do something differently as well. I don't know. I don't know how that stuff works actually. Anyway, let's toggle that off and go back here. So let us play the intro animation and see what is actually happening here with Vulkan. And I think I'm gonna actually probably turn off the VSync here. So we're running at an unlocked frame rate. Yeah, we have a little bit of overlapping music now. Let's turn off the epidemic sound music for a bit. I'm just like watching for things that may or may not work. Or rather, watching for things that don't work.
They sent me down from orbital to make a documentary, Life on the Surface.
Oh yeah, AI voices.
Right along with the cargo crew, interview some folks, shoot some footage.
What you will hear next is actually not AI voices.
There'll be someone at Minerva.
It's been 3 days since the alarm.
Lift station's manned round the clock. Always has been.
Used to be. What's that?
Source, refinery sector.
Elevator all right? We'll know soon enough.
So that was actually like
I've been promised
the
to move
test
right along. This was
dialogue
rapidly
that we
becoming
recorded
something else.
with the voice actors some time ago and just stuck them into the game, waiting for the rest of the lines to be recorded and mixed and everything. So we do actually have a little bit of voice acted dialogue in the game, but most of it is still AI voices.
Here we are. Minerva lift station. Fastest way up to the plateau.
At least the elevator's still there. After you
Anyway, that looked good. At least I couldn't see anything, you know, obviously wrong with it. So
Minerva station.
that's pretty
This is
great.
Lord Lance, comms operator of cargo platform 34. Do you copy? Channel open. Adjusting position. No answer. Let's go have a look.
Oh, what about the... Oh, look at this. Volatile constant buffer, nano VG rendered, PS constant CB has max versions 250, which is insufficient. Wow. Okay, first Vulkan problem. I'm gonna copy that and put it into a file. So what we're doing here then, I guess, is we are rendering the we're rendering the UI, and we're writing so many times to a volatile constant buffer that it blows the buffer that we have set for it. That's interesting. I was thinking like for sure, like I think that's 250 right there. I was thinking for sure this is going to be enough, but apparently not. Let's see if we can actually reproduce this first of all. Yeah, unfortunately this intro can't be skipped currently. I should probably add skipping to this as well.
Elevators still there after you vet.
We'll be right behind you.
So what did we do? We asked Mother to come here.
Adjusting position. Minerva Station. This is Rowan Lance, comms operator of cargo platform 34. Do you copy? No answer. Let's go have a look.
You can see the seam between the two terrain objects there underneath the car. So slightly different lighting on them. Right, so switch to this and gravity crane. No? Now it didn't crash. Okay, so I think it's probably straddling the... I think it's probably straddling the limit there. Look at that, the actual displacement effect works though. That's nice. So this is also a compute shader effect. And that's nice to see it working as well. Although I guess we would have seen it because the eye adaptation is also using a compute shader. So we actually wouldn't have seen anything if compute shaders didn't work. Well, we would have seen UI basically. But nothing 3D. Okay, let's lower this down. Blonk. Get this up here. I wonder, what do we need to do to get...
Diego here. Yeah, talk to me.
Like all of this is actually geometry, even that ping thing,
Diego here.
the radio ping and everything.
Way.
All of them are actually geometry, vector graphics, more precisely. And so any of them, I guess, could trigger that thing that we saw. And you might be wondering, okay, why don't we see it on D3D12 then? Well, because D3D12 actually doesn't have that recycling business that Vulkan has on NVRHI. Maybe try replaying the whole interest before. Yeah, I mean, that might be it, but when the intro dies, I don't think it shouldn't leave anything behind. But you're right. Maybe we should try playing that back once more. That's true. I mean, the intro has some pretty complicated shapes and things like that. But we might actually have more complicated shapes here in like the sandbox menu. This all works fine. Options. Yeah, all of this works fine. Oh yeah, we can try playing this again. I'm gonna silence it. It can play there in the background. So max versions, I think this is only valid and required to be non-zero for volatile buffers on Vulkan. So this is only used on Vulkan. You need to tell NVRHI how many times you're planning to write to this buffer during one frame, essentially. So how many things it needs to, how many versions of your data does it need to keep track of, right? In flight at the same time. Excuse me, I'm kind of losing my voice here again. Like always. But yeah, okay, now we have played like through the parts. I'm gonna skip this now, and then I'm gonna do the same thing again. So I'm gonna go back to the menu, and then I'm gonna play through. Oh, now I did something stupid. We need to clear that save slot. Yes, clear the slot, and then yes, start a new game, and then we can get the same thing again. So all of this is actually geometry. That's why it looks so crisp and nice. But that, of course, means that we are going to be writing to this CB description quite many times. So it's, yeah, VS constants is the name of the buffer. So it's writing to it when we do render viewport. And where do we call render viewport? Well, it's called from a render viewport. Quite simply. And this guy is probably called from inside NanoVG, right here. And it's just called begin from begin render or from begin frame. NVG begin frame. Huh. That's interesting. Okay, so we're still running the intro here. Shouldn't be anything particularly heavy UI wise after we have the beginning there. But let's let it run to the end. I'm a little confused here by the fact that we seem to be writing to this guy at the beginning of the frame. And these are like IMGUI things. So they shouldn't even really be called or have anything to do with this. Well, let's mess with it now that we have played through the intro a couple times. And we can see what's happening here.
Service station. This is Rowan Lance, comms operator of cargo platform 34. Do you copy? Channel open. Repositioning. No answer. Let's go have a look. Listen.
All right.
Adjusting position.
I was doing something like this. just, you know, normal messing around with the UI here and seeing what happens. Have the unstuckifier UI as well. Trying to sort of come up with all of the different views that I have here. But yeah, that should be fine. All of that should be fine. So we have NVG begin frame. I think this is called exactly once. Goofy manager. It's called here manager render. We call begin frame. Then we render the so-called periphery, which is like the black background that you see if you're not filling the whole screen. Then we render all the stacks, all the views in the stack. Alright, we have a periphery mode before and or behind rather, and in front, and then we call end frame. So this should be fine. Hey, I wonder, doesn't have anything to do with the frame rate. Desync off. If we have a higher frame rate, can that actually... Like, we should still only have 3 frames in flight, right? Yeah, look at that. It immediately blows when we have a higher frame rate. Interesting. Let's copy this here. Yeah, it's the same thing. Let's copy the call stack as well. So, yeah, end frame. Oh, wait a minute. It's the PS constants. It's not the VS constants. It's the PS constants. What was the message here? PS constants. That's max versions 250, which is insufficient. Oh. So PS constants has the same thing. Okay. Yeah, okay. Yeah, they both... Oh, right. Okay, yeah, I was looking at the wrong thing, quite simply. This is the one that has 250. This is the one that has 10, yeah. And I guess technically this could have, like, maybe 3 or 4, like the number of frames in flight, which is 3 currently. Yeah, okay. Okay, this makes a whole lot more sense. So now we have... Now we have more frames. Now we have a higher frame rate. We should still not have more frames in flight. But it probably just means that now we are actually having more than 1 frame in flight, right? Or maybe 2 frames. Or however many up to number 3. And that means that we can have more than 250 updates. Okay. Yes, this makes sense. Let's do one more sanity check here. Make sure we can reproduce this reliably. So let's do like refinery, Vulkan, and I'm gonna do render options. I'm just gonna turn off vsync by default here for the time being. I mean, you can do it in the options menu as well, but it's just easier. This is just easier. So now if we add... maybe we can even reproduce it with this one. No, not quite. Not quite. But we can add a mother here. We're still... What? Okay, I guess the options menu kind of overrides that then. Alright, well, let's undo that. And I'm going to go to app data, trampoline, and then we have the options configuration file, and we're setting vertical sync to false. I'm just doing it the long way here, because I'm not going through the menu now, and I just want to see. Yeah, now we have like thousands of frames per second. Cool. Okay, can I... No, this one doesn't blow it. But I think immediately if we switch to mother and to one of the cranes, because we'll be getting the inputs up here in the left top left corner, like that. Okay, it's not blowing it immediately, but it's blowing it pretty quickly. So yes, okay. That looks good. So let's just first of all see if we raise this to like 350. Does that fix it? Or do we have like a case where, you know, if we raise it to 1,000, it's still breaking? Mother. And I think it's probably this one. Right, so 350 doesn't fix it. Okay. So we're gonna go balls in and raise it to 850 now. Let's not mess around. I think this should fix it, because if 250 is okay for one frame, and we have 3 frames in flight at the most, then 750 should cover it, so 850 should definitely cover it, right? So now we should not be able to get that. No matter how we change the camera or anything like that. In other words, no matter how high of a frame rate we have. I'm gonna try to fly down here and see, can we get to like 400 frames. Very occasionally. Well, now we're seeing 400 frames. We're still not getting any issues. So yeah, I think I understand the problem now. Now, of course, the annoying thing here is that, like, okay, are we really writing 250 times to the buffer? If we are, then we might want to see if we can improve the NanoVG renderer backend a little bit. And of course, like, the NanoVG renderer code is not actually NanoVG code. It is my NanoVG rendering code, because NanoVG doesn't really come with a renderer. I mean, it does have an OpenGL renderer, which is pretty old as far as I know. But I don't use OpenGL, so I had to write my own renderer, and that is where we have the issue now with Vulkan. So I think we might want to actually change that so that it doesn't need to do all of those individual writes, if it can help it. But we'll see. But okay, we found an issue. That's good. I mean, it would be kind of hilarious if we didn't find anything. So that's completely expected. And it was not something, you know, something like having to play the intro, although that was a pretty good, you know, pretty good idea and thing to follow up on. But even though, like, the cargo crane here doesn't look very complicated, rendering all of these, well, I can't even really show them. If I move the mouse, it switches to keyboard and mouse inputs, but like these gamepad controls that you see there in the top left corner, they're actually kind of complicated to draw as like vector graphics, which is, you know, arguably why you shouldn't do that. You should at least, you know, cache them to a texture and then render the texture or whatever. But yeah, my UI system doesn't do that currently, so boo-hoo. Okay, what else can we break? Is what I'm wondering. Let's see. Yeah, we can hear the gate if we put the camera close enough to it, but the camera is so ridiculously high up when you're driving this vehicle that like it's kind of tricky to hear anything. Is the GUI custom or just ImGUI? Yeah, it's a little bit of both. This is ImGUI, this thing which shows the frame rate and the Vulkan text there, and this top bar is ImGUI. So we have a whole bunch of like, render stats, GPU profiler. This is all ImGUI. Basically the normal things you would expect. But then the in-game menu, like this stuff, is custom. And it's the same thing that's used for all of the menus and everything. Like this stuff is all custom. So they both have their places. ImGUI is super handy for all kinds of things. Like we can debug, for example, this vehicle here. We can see things like gearboxes, engine RPM, this sort of thing.
We'll be right behind you.
So you can open like
Minerva
these
Station.
debuggers
This is
for shut up for a bit there, thank you. You can open debuggers here for all the vehicles, and this kind of thing is just super handy to have to use ImGUI for,
Comms operator of cargo platform 34. Do
as
you
I'm sure
copy?
you'll know.
Receiving.
But it's not really
Position.
it's not really very nice to use for like player facing things, right? Let's turn on the VSync again, get a little bit of a smoother experience that way. My mother's just driving over the rock there. Okay then.
The opportunities directly within effect. Remain calm. Proceed directly to the starport. Do not delay.
Yeah, that is actually also a voice actor reading those lines. I think it requires a little bit more processing before I get the feeling exactly right, but it's pretty close.
Receiving.
Yeah, for example, that radio ping, which kind of starts here on top of the vehicle and then expands outwards as a ring, like
Channel
whoops,
open.
that sort of thing.
En route.
I mean, I guess technically we can perhaps do it with ImGUI, but it's not really designed for that sort of thing, so it's a little difficult maybe to do, but maybe you could do it. ImGUI also doesn't have like super advanced text rendering, so if you wanted to do this with where you have like this glow for the highlighted text, I think that could be kind of tricky to do with ImGUI as well.
Receiving. Repositioning.
But yeah, I mean, so far, pretty excellent progress here. I think the fact that we are hitting that 250 right limit there might just mean that we should take a look at the UI renderer and see if we can bring that count down rather than trying to bump up that buffer. I mean, it's probably not super bad if we had to do it. Let's see, how big is this actually? Size. Right, so this is like there's a matrix, there's some vectors, it's another matrix. It's actually a fairly sizable struct, this. Let's see, how big is that actually? If we just restart the thing. Locals doesn't want to show me size, does it? Apparently not. So it's 288 bytes. If we do a little bit of fast napkin math here, 288 times 250. And then we divide that by 124, that would mean 70k. So if we have, you know, 850 like we have now, then that would be, well, it's still like 250k. So like in terms of, you know, however many gigabytes of video memory you have, it's not really anything. Like this GPU I have now has 16 gigs of memory, but what is perhaps more concerning is the fact that like we're writing 250 times or close to 250 times per frame to a buffer. That's bound to come with some sort of performance penalty. So yeah, that's not great. All right, what should we do next? I'm struggling to think of things that I haven't already tested. Oh, I know what we should do. We should test my previous game project, which has some effects that I don't really use in Traction Point, because this is also running on the same engine, and this is probably, yeah, it's running on D3D11 now. We can see here, let's log into the asset server, but it is loaded plugging basis D3D11. So that means that we need to probably hack this game to load Vulkan. But we can do that, that's not a problem. This game, of course, never really got far enough to get an options menu or anything like that, but it does have a little bit of a different art style, and it uses things like water effects, for example. Alright, we are logged in. You can see, yep, it has some resemblance to Traction Point. It's kind of the progenitor of Traction Point. Yeah, the options menu doesn't do anything, and we're rendering in D3D11 mode. So I'm just gonna find this here, and I'm gonna replace it with VK for Vulkan. And here we go. So, new game. And we get a nice little intro animation. So far so good. Frame rate looks alright. What do we have if we are unlocked? About the same, 200, 250-ish. Water looks correct, that's nice. This game is written entirely in C++. It doesn't have any Zig. It's like one big thing. So it doesn't use the so-called trampoline at all. It's using just my game engine and C++. Let's see how does the water actually look? We get like real-time reflections from the car there, as you can see. We don't get particles. We would actually get new traction point style particles, but we don't get this old style particle thingy that we have going here. We also don't get any bloom in the water. That is expected, and if you actually look close enough, you can see that we don't even get any transparencies in the water. So you can maybe just about see that the vehicle doesn't actually have any wind screens, because they are rendered the transparency pass. I don't remember why I didn't do that. Maybe that was just like an assumed optimization or whatever. Let's play this game a little bit. This is actually kind of fun. I mean, it never really went anywhere. This game has like actual combat and everything. And this is the game that I was making kind of before I made Traction Point. And it's in some ways it is the same game. It takes place in the same universe even, but slightly different, slightly older version of it. And yeah, we have guns now. We can shoot, and we get particle effects. A pretty annoying gun sound. We also have a rail gun, which doesn't have any effects at all. And you can see that we can't aim it. It just has this debug draw line that comes out of it, so you can see where you're aiming. This thing is like ridiculously overpowered, so you can one shot kill enemies with this. But you need to charge it first, and then you need to line up your shots. Shoot that guy. Boom. And the AI in this version of the game is like super stupid. So they don't really realize that their friend has blown up there. As long as you don't show yourself to them, they won't notice you. And we're gonna sneakily drive up here. I mean, so far everything looks fine. This is now running on Vulkan. Seems to work perfectly fine. So now if we drive up to this guy, he's starting to shoot at us. We can't have that, so we're gonna blow him to pieces. Bye bye. And here's one guy who tends to drive into a ditch and get stuck. And he has once again done that. I'm just gonna shoot you as well. And then we have one more, and he's right here. Hello. And they can sort of fight, except they're super bad drivers, so they drive into things all the time. But they can sort of fight you a little bit every now and then. And here we have a couple more. Kill you. There we go. Alright, so now our friend should be heading this way. I wonder what happens if I shoot him. Did I actually implement some sort of logic here to fail the mission if I do? Boom. Apparently not. We still have the objective marker there on the garage. But Diego, poor Diego is never gonna make it there because I blew him up with my railgun. Oh well. Oh well, can't be helped. Post-combat. What happens now? Now Diego is actually supposed to like teleport in here. Is his hunk of a car actually supposed to like going to teleport in here? Let's see. Yeah, it just appears, but it's been destroyed. Oh no. So sad. Okay, anyway. When it comes to Vulkan, this all looks perfectly fine. Which, I mean, I guess I shouldn't be surprised, because it's running on the same engine as Traction Point. It's using like one or two more effects that Traction Point don't really do. There's a bit more transparency here with this particle, like dust particles and all of this. Traction Point is more stylized, cartoony, one might say. But other than that, it's basically the same tech. So I guess I shouldn't be surprised that this works kind of okay on Vulkan as well. Yeah, you can hear that we don't really have any impact sounds for anything in this game. Never really got that far. Yeah. What if we unlock the frame rate here? Pretty sure the frame rate is gonna tank here. Yeah, it goes down to like 90 when we're looking out on the level from this direction, and we have the water there, so it needs to render it like twice basically. Because there's no like screen space reflections or anything like that. It actually renders the scene just 2 times. Or 3 times even, because we're rendering reflections and refractions separately. Yeah, I still like the look of this game. I think it looks pretty nice. It was just way too work intensive for me to make. So I had to kind of ditch it because of that. There's still some clearly unfinished stuff here, though. Okay, well this looks good. I don't really see anything wrong with this, so that's nice. I think we can probably bring back D3D11 here. What then? Do we have some interesting test levels here that we should test? Something that does something very unexpected and weird. Most of these probably actually don't don't really build currently because they're like old stuff. We could go to the descent. That should work. Just make sure that we actually actually it doesn't work. Let's see, what is this? This might be just a material that I have forgotten to go here actually. We should see the base. Base is resource path. It's right there. Map descent materials plane far. So if we go to the resource manager or asset browser is the name of this. Plane far, right? We open this up. So material properties, it does not have only explicit exports. Like this is sometimes ticked, and that means that if I do a batch export, it doesn't actually export those materials, and then you have issues like this. But it wasn't ticked, so why has this not been updated then? That's strange. It does update now at least. Map depot is that one, okay. Map descent has just the plane far. What about these guys? Right, this is the material variant. So that would have been converted. So I spoke earlier about the fact that when I made that shader compiler change to make Vulkan work, I needed to make some changes to material formats, basically adding those new values that we looked at, but that I can do that with a batch export. Well, for some reason that plain farm material doesn't seem to have been exported. I'm not exactly sure why, but now it should work. So now if we go to map descent. Oh, still not. Integrate shader program description binary file. Wow. Full name: environment plane, quick mesh, and mesh. Up to date in the cache, no need to convert. Ah, that's probably the reason then. Plane far, yeah, we can actually can find it from here. We can do plane far, and then we do a convert, do a forced conversion of it, basically like that. And let's try one more time. Yeah, we can keep the vsync off for now. Haha, still nothing. Yeah, we're loading the correct project there as well. Well, that's strange. Up descent materials plane far. Okay. Pin material. It's that one. Yeah. What's happening? Very strange. Bin material. Shouldn't the bin material look a little different? Let's go to refinery, for example, and go like bunker doors bin material. Okay, yeah, they actually kind of look like source code when you start reading them, and then they like probably, you know, sooner or later they get some binary data included in them. Yeah, like here. That's probably some like binary blob for something. Okay. Same thing here. Yeah, we have some like binary stuff. That's probably actually fine. The question is though, how can we keep getting that same material file over and over? And in particular, how can we keep getting it with the wrong version? Very strange. Let's compare these two guys. They're kind of related. I think they used to be the same thing. One is just copy pasted from the other. Materials. Yep. These guys. We have map depot. Gonna compare that to that one. Okay, so here we have clearly, we have like version 10 is like OA, as I'm sure you know, in hexadecimal, and here we have 09. So we're writing version 9 to the map descent, we're writing version 10 to map depot, and this is the version number that it is getting cranky about. Okay. That's not good. So if we open this up, we are in map descent materials plane far. Let's export this guy. Okay, so now we actually got it. Maybe the thing was just that we were converting the wrong file. Was that maybe the problem? I think so. Yeah, I think I was just accidentally converting the map depot version, because we can see it from the timestamp here that it was modified just like 7 minutes ago or 8 minutes ago. Okay. Well, that looks better. Let's look at this one more time here and see. Yeah, okay, so here's the actual reason why this wasn't being batch exported. It had the only explicit exports flag set. So now that explains it. Okay, so these two need to be submitted after the stream. So now we should finally be able to load into that level. A little bit of a mix-up there. On my behalf. Map descent. Here we go. Here we go. Right. I need to get back to working on this level pretty soon. I basically have just like a little bit of audio work left to do in the refinery level. Then we can finally put that level behind us and consider it done. this one has a lot of stuff to do still. There's supposed to be a whole area that way, which is not done yet. But it's already pretty fun to drive around, especially with the mother vehicle. It's such a big beast. You get a pretty good kind of look at this area from the mother vehicle. Although the scale might be a little bit all over the place with this. Especially since we don't have any like trees. Well, we have like 1 or 2 trees over there, but like we don't have a lot of trees and things to like actually set the scale here. So you don't see here that this tunnel is probably like 30, 40, maybe even 50 meters high, because everything is so huge. And yeah, here we have a little bit of back face culling thing. This is not a Vulkan issue. It's not just something that hasn't been fixed in the level yet. So no need to worry about that. And then we have some unfinished mountains. No, my wheels are glitching out. Oh yeah, this is kind of an unfinished area. Oh, this look interesting. Z fighting, of course. I think the pattern is actually kind of different on Vulkan than it is on some other APIs. But maybe I'm remembering it wrong. And yeah, no catastrophic failures yet. Kind of starting to think we're not gonna really see that. Of course, like one thing that we probably want to do still before we kind of consider this working. Well, I mean, I do have a UI buffer bright thing to fix, but other than that, I think we're gonna want to load from one level to another. Take all of these like larger levels that I have, load into them, load out of them, load like another level, and do that a few times, because that tended to be a pretty good way to get D3D12 to crash back when I was trying to solidify the D3D12 paths, because D3D12 and Vulkan have all kinds of like limits on how many resources of a certain type you can create and things like that. That like D3D12 kind of, or D3D11 abstracts away from you. You don't really have to care about how many samplers you create, for example. That was one of the bigger issues I had with D3D12 when I tried to get that working. That you can't just like create samplers willy-nilly. There's a very, very real and hard limit on how many you can create. And so loading between levels was a very good way to hit those limits. So let's do that. Let's go back to the menu here and then load into refinery. All right, seemed to work. Let's go back out. Load into depot. Seemed to work as well. Only warning we got is that we can't create a game object because we don't have a spawn point set. That of course has nothing to do with graphics. let's go to the maybe map stairway. It's one of the sandbox levels. I should really have a competition, a level making competition at some point for you guys. So that we would get some more sandbox levels. Do hit me up on Discord if that sounds like something that you would actually want to do. I can hook you up with the level editor already, even though it's not yet actually released for modders. It is going to be at some point. But if there's someone who would actually like to make sandbox levels, do let me know. We can figure something out already before it's like available for general consumption. Whoops. That's unfortunate. Luckily we have the unstuckifier. It's probably like the most solid system I've ever built, that unstuckifier. It just works. It does its job like a champ. It's just absolutely wonderful. And it was also built on stream, by the way. Probably around a year ago or so. I'm just gonna jump down here. Whee! Oh, and by the way, if you want to play this game, you can do so tonight. You can do so in 5 minutes. The only thing you have to do is join the Discord, and you get access to the Steam playtest. If you don't want to join the Discord, you're gonna have to wait until there's a public demo. But the public demo is getting worked on all the time. It won't obviously require you to join the Discord, but if you want to play right now and you want to play one of the pre-alphas, you can do so by joining the Discord. And there's a pretty recent pre-alpha number 4 out, which is about what is it, maybe a month and a half old. What else? Proto test level. That probably doesn't work. No, it's an old level. Okay, well, we found one material. It wasn't really like a Vulkan thing. It was more like an asset data thing. But still, good to get that sorted as well. Alrighty then. What is next? I don't really think we have a whole lot of more like assets that we couldn't have reached already with the levels that we tried, but let's see. I'm gonna see if I can transport these guys up there into the receptacles 2 at a time. Can I do 2 at a time? think I might be able to do it. So like when it comes to actual like future plans and why I did this Vulkan thing, I don't think that I'm gonna put like a whole lot of effort into making Vulkan like my main graphics API or anything like that. It's nice that it works. It's a little sad that it is clearly like slower, simply on the NVRHI level compared to D3D12. But it's nice that it works, in particular because it does mean that later on, if I want to make an actual native Linux build, I can make that happen. But I think I will basically see what I can do about that UI buffer thing, which, you know, we could do right now, but I think I need to look at that a little bit further. So I'm not going to do that now. Because it's going to be one of those things that I talked about in the beginning, that is like not necessarily, I don't exactly know what I'm doing there, so I'm going to want to do that like in peace and quiet and not try to be, you know, entertaining or whatever to you guys, because I don't think it's very funny or interesting stream content necessarily. So I'm not going to do it now. I am, however, going to do it so that we can have a solid Vulkan backend that we can ship with the game for anyone who wants to try it out. And it will remain kind of experimental, at least for a while. Fair warning, by the way, the game might get utterly bonkers now, because this level has a little bit of a bonkers script to it. If I put this power cell here, we start spawning dynamic objects over there, and I think we basically spawn them until I remove one of those things, or until the game crashes, basically. So yeah, it's a little crazy. At the end, it just like starts glitching like hell, because we have so many of these boxes and things. But I guess we should stress test that with Vulkan as well, shouldn't we? But yeah, based on a very quick test that I did yesterday, last night, because I kind of, my hope was that the game would run a little faster on Vulkan on the Steam Deck, because of course Steam Deck has Proton, which translates D3D12 commands into Vulkan. So my thinking was that, like, if it is already Vulkan, then there's less for the Proton layer to do. Well, it actually turns out that, at least with the current NVRHI version and the way that I use NVRHI, it is actually faster with D3D12. Not a whole lot, but a little bit. 10-15% faster, roughly, than it is with Vulkan. So there's clearly something that like NVRHI does a little strangely with Vulkan there, or then it's just like it's not optimized for my use case. That's the other option. But that just means that like D3D12 is going to remain my main API for a while, especially since it works on both Linux and Windows through Proton. So my opinion on it hasn't really changed because of this, but it's very nice that we finally have a working Vulkan backend as well, obviously. we're kind of spawning the same kinds of objects over and over, and that means that the mesh is the same, the material is the same, we're just like instancing more of them. And because of that, the performance doesn't really suffer from this. The performance is probably going to start suffering like on the physics side soon. And you can see that like those objects are kind of like not really even fitting there anymore. They kind of throw each other away when they spawn. But yeah, I don't think we have any issue with this and the Vulkan backend. Let's see, can I actually even drive this thing out of here? Yeah, I can. So this is of course what the trucks looked like at the very beginning of the project. Just very kind of basic blocky things. And then you have the gripper truck up there, which is like the fully realized version of it. Okay guys, I think we are probably approaching the end of what I had planned for this stream. We're falling off the world here. But if you have any questions at this point about Vulkan or about the project or about anything really, don't be afraid to ask. And if not, then I think we're going to probably call it a night soon. So next week is going to be I'm going to be very busy with other work, non-madrigal work. So I'm sure there's going to be a little bit of a slowdown in updates, but we'll see how that goes. I had an idea for a physics related video, which is kind of a follow-up to the box 3D physics video I did a few weeks ago. So I might still do that during the weekend, but we'll see how that goes. And if that goes. But yeah, I think we should expect there to be slightly fewer updates for like a week or two when I'm busy with other work, and then when I come back to Action Point, things will pick up again. But like I said, I'm not doing this full time, so occasionally there will be weeks when I will be out doing other things. Anyway, this Vulkan backend is basically working. That's my assessment after all of this. It's basically working, and it's working kind of surprisingly well almost. We have that UI buffer thing. Other than that, it's basically all good in the hood. Oh, I'm rendering at 90%. That's stupid. Let's not do that. Actually, does that work? I don't think I've tried that. Let's see if that works. Let's put it down to 50. There should be like a a visible drop in you know, quality, we can just go to that same sandbox level. Yeah, that looks correct to me, I would say. We can actually even, we can select it from here. We can do render a dot render scale. So it's at 0.5. If we put it up to 1, we can see that yes, we get some clarity back. And that looks alright. We can put it down to something ridiculously low. So now we're looking at like a VGA game or something. We can put it down to like super ridiculously low. Beautiful stuff. You can almost not see what is happening. And now we have like, now we can like count the pixels. It's interesting that you can see sort of you can see some more like high quality shapes here in these pixels every now and then. It's probably the AA, SMAA trying to do its thing. It has a little bit of a hard time when the resolution is this low. Anyway, the render scale works as well, so that's nice. And this is what we actually set in the options menu. You can't go, you know, below 0.5 in the options menu. It kind of doesn't really make sense. But it does work, so that's nice. That is nice. Yeah. And of course, the UI always renders at full scale. So the render scale is just the 3D parts. Excellent. Alrighty then. If no one has any questions, I think we're done for today. Thank you for tuning in. This was a pretty chill stream. And just a few little things to look at, but overall very happy how this is turning out. And it was that Vulkan follow-up stream I promised you guys. Quick reminder, if you want to play the game, you can play a Steam playtest build today, which has this very level. And you can do so by joining the Discord. Do remember to like and subscribe. Subscribe to the main channel and subscribe to the live stream channel, which this is. My more kind of produced and edited videos go up on the main channel, and this one is just for live streams. So depending on which one you are interested in, join one or two or neither, however you like. If you want to help out the project, go to Steam and wishlist the game. There is a link to that in the chat and in the description and so on. And if you don't want to play the game but you still want to kind of talk about these things and hang out, then Discord is an excellent place to do that as well. Kind of feels like every other person there is making their own engine and building a game or whatever with it. And we are all very chill and friendly over there, so do come hang out if that sounds interesting. With that, I thank you for your time. I wish you an excellent weekend and the rest of your night. See you next time.